Hi students, this is Naveen. Today we are going to solve one more important problem from capacitor's concept. Let's solve the problem. In the given figure, a capacitor of plate area A. This is the capacitor in this figure. What is the area of the each plate? A. It charged up to charge Q and each plate is charged up to Q. The mass of each plate is M2. What is the mass of each plate? Each plate mass, let us think this is M2 and this plate mass is also M2. The lower plate is rigidly fixed. The lower plate is rigidly fixed with a rigid support. The value of M1 if the system remains in equilibrium is. We have to find out. What we have to find out? The value of M1 if the system remains in equilibrium. Nothing but the net force is equal to 0. Simply we can say that the net force acting on M1 is equal to 0. Nothing but there is no force acting on M1. Now how to find out the mass M1? If you observe, the mass is hanging by a string. The force which is exerted by a string, that is said to be tensional force. Here the tensional force is in upward direction. Now we are going to draw the free body diagram of mass M1. If you draw the free body diagram of mass M1, the downward force M1g due to the acceleration due to gravity and upward force T. From this T is equal to M1g. If you draw the free body diagram of, this is the free body diagram of mass M1. From this, how can you write the downward force M1g, the upward force tensional force T? From this you can write as T is equal to M1g. It is clear. In same way, you have to find out this tensional force also. If you observe, they are giving each plate is M2. If the capacitor charged up to Q, let us assume this plate becomes positively charged, this plate becomes negatively charged. If the both charges are opposite to each other, what is the force between them? It is in attractive in nature. From that, we have to draw free body diagram for the upper plate of the given capacitor. Upward force, tensional force, downward force. What is the mass of the each plate? M2. The downward force M2g. The force in attractive nature. Here the force also is in downward direction Fe. And what is meant by Fe means where Fe is the electric force. From here, how can I write the equation? T is equal to, here M2g and Fe both are opposite to T. T is equal to M2 plus Fe, M2g plus Fe. It is clear. From this, how to find out Fe? We know that T is equal to M2g plus Fe is equal to, I can also recognize QE because I know that Fe is equal to QE and T is equal to M2g plus Q into, what is the E? In parallel plate capacitor concept, the electric field of each plate is equal to sigma by 2 epsilon naught. In parallel plate capacitor, the electric field each plate is equal to sigma by 2 epsilon naught. This is the formula for parallel plate capacitor. This is the electric field for the each plate, not total plates. Each plate, the formula will be sigma by 2 epsilon naught. From this, I can get T is equal to M2g plus Q of sigma by 2 epsilon naught. And how can I write this one? T is equal to M2g plus Q of, what is the sigma? We already know that Q is equal to, what is the formula? Sigma A, where sigma is the surface charge density. From this, sigma is equal to Q by A. Substitute the value here. Therefore, T is equal to, this is Q. Q into, instead of sigma, if I substitute Q by A, it will become Q by 2A epsilon naught. It is clear. Finally, I got T is equal to M2G plus q square by 2a epsilon naught. Let's assume this is equation 2, and here we have one more tip. Here let us assume equation 1. If you observe the whole string, the tension remains same in this whole string. Nothing but here these two tensional forces are equal. T is equal to T. From equation 1 and equation 2, how can I write? M1G T is equal to M1G is equal to M2G plus Q square by 2A epsilon naught. From this, if you want to find out M1, because they are asking the value of M1 is equal to M1G plus Q square by 2A epsilon naught whole by G. It will becomes M2 plus Q square by 2A epsilon naught by G. It will becomes Q square by 2A epsilon naught G. Finally you got M2. Finally you got M1 is equal to M2 plus Q square by 2A epsilon naught G. Whenever the system remains in equilibrium. Till now it is clear. This is the M1 value. Now, shall I repeat the whole procedure? First of all, you have to observe the tensional force here. This is the tensional force of the string. This is also tensional force of the string. In this one, the tensional force remains same. And next one, I have to draw the free body diagram of mass M1. From that free body diagram, T is equal to M1G, and on other side, I have to draw one more free body diagram here. In this free body diagram, I got tension force T is equal to M2G plus Fe, where Fe is the electric force. We already know that F is equal to QE. From that I can write T is equal to M2G plus QE, and E is equal to electric field. Electric field of each plate of a parallel plate capacitor, E is equal to sigma by 2 epsilon naught. From this, T is equal to M2G plus Q into, if you substitute the value here, it will become Q by 2A epsilon naught, and we have one more formula. Q is equal to sigma A, where sigma is equal to surface charge density. From we got sigma is equal to Q by A. If you substitute the value here, T is equal to M2G plus Q into Q square by 2A epsilon naught. From the equation of 1 and 2, I got M1G because the tension remains same. Remember, the tension remains same. M1G is equal to M2G plus Q square by 2A epsilon naught. It is equal to, from this M1 is equal to, if the G transfer here, G cancel, and remaining Q square by 2A epsilon naught by G, it will becomes M2 plus Q square by 2A epsilon naught G. This is our required answer. Finally, you got the value of M1 is equal to M2 plus Q square by 2A epsilon naught G. Is that clear? Thank you. Thank you all of you.